EPTAR reinforcement is a tool for civil engineers who are working in ArchiCAD and would like to make reinforcement drawings of concrete constructions. It also provides a good opportunity to check the position of placed rebars, meshes, stirrups, and complex elements in 3D. In the beginning, I will show you the main functions of the reinforcement add-on in some slides. Using this tool, we can easily place prepared standard shapes and freeform reinforcement bars. We can automatically insert reinforcements into beams and columns and create a list of applied reinforcement elements. Workflow. In the Model View option, we can set default settings for the whole project. These settings are the diameter and the correspondent weight, the pen color of different diameters for representation in 2D drawings, and 3D model view. On the second tab, we can set parameters for the drawing and text fields. When we would like to place a reinforcement element, first the Object Settings window will appear, where we can select the reinforcement element type, shape, and position of it in the construction, as well as other technical parameters. After we set all the necessary parameters for the element, we can place it into the concrete construction. It is possible to do this freehand or by using the automatic option of the add-on. Of course, we can combine these methods, place some elements by hand and insert others with the automatic option. Next function is a complex element. Complex elements are those that are combined from some different elements for columns, beams, and crowning. After we place the elements, we are able to easily create a cutting list of them. This cutting list will collect all parameters of the selected items: shape, length, weight, and quantity. It is presented in details and summarized in the special table, which can be placed on the floor plan next to the drawings. Here, some drawings are visible, which were created in ArchiCAD using the EPTAR reinforcement add-on. Now let's see how we can use it in ArchiCAD, how it can help in our work. After installation, the program appears in the EPTAR Solutions/Reinforcement menu in the menu bar. In this menu there is a Load Library, Registration, and a User Manual option. The registration is important because, as with all EPTAR solutions, reinforcement also works with an online protection key, so it should be registered before use. The online protection key means while the user is working with reinforcement, their computer has to have an active internet connection. If the connection is broken, the reinforcement license will switch to demo mode. The demo is limited in functions but available for everyone who would like to try it. After registration, we can start working. First, we have to get the toolbar and load the library. It is important because the library is loaded automatically when ArchiCAD starts. When it is done, the reinforcement palette appears. With the tools of this add-on, we can place reinforcements into walls, slabs, beams, columns, and slanted elements like a roof. Let's start with the wall. Let's place reinforcement into the wall. I prepared 3 simple wall combinations. The first is a mesh. I select the walls where I will place the mesh element and click on the wall tool on the reinforcement palette. The settings window appears. On the left side, I select the mesh. On the first tab, I can set diameter, quality, position of mesh, and the 2D representation. On the next tabs, I set table size, table distribution, then 2D appearance, text type, and different labels. In every settings window, there is a checkbox marked Global Settings, and if it is on, the program will use the settings selected in the Model View option. When all parameters are set, I click on OK. Now with this eye cursor, I select which side of the wall I'd like to place the mesh. I click outside on every wall. When I clicked on all selected walls, the add-on asks if I want to place more elements or not. I choose the No More Reinforcements option. The mesh is placed into all selected walls. As we can see, if there is an opening in the wall, it will be cut out from the reinforcement. Check it in 3D. In a wireframe view, all mesh elements are visible in the walls with the holes where there are openings. Back to the floor plan, and I place one more window into this wall. The add-on calculates the new hole in the wall automatically and cuts it out in the already placed reinforcement. I check it in 3D. If I want to add more reinforcements, for example into the other side of the wall, I just select it, click on the wall tool icon, select the reinforcement type with the necessary parameters, and click on OK. With the eye cursor, I click on the inside of the wall, then no more reinforcements. The mesh is placed. Important to know that the add-on will always get information only from the core of the wall and will only place reinforcements into it. This means that the reinforcement will only be placed into the load-bearing construction. Now when elements are placed, I can adjust the position of the 2D views of the mesh. Move it, rotate it, or replace the text and label type and content. If necessary, I can rotate the mesh inside the wall. The rebar works like the mesh. I select all walls where I want it placed. Click on the wall tool in the reinforcement palette and set the position of the rebars. This is important because in the wall it can only be vertical or lateral. I select vertical. On the next tabs, I set all other parameters, like the shape of the rebars, and click on OK. Like in the case of the mesh, the eye cursor appears. I select the necessary side of the wall and click. When finished, let's see it in 3D. Here it is. Now I place one more door into this wall and check it in the 3D window. The add-on calculated a new opening in the wall and reinforcement. Next reinforcement type which I can place into walls is an edge element. It is a complex element which contains rebars and stirrups. I select the walls, click on the wall tool, and I select the rf_edge element from the list. Parameters and position should be set. In a wall it should be vertical. There are no more parameters that can be set. With the eye-shaped cursor, I select the wall side. Let's see it in 3D. It's good and visible that the complex element is placed in all edges of all selected walls, including the edges of openings. Of course, the position and all parameters of the placed reinforcement can be changed. I select it and open the settings window. Now a lot of parameters are available. I want to change the stirrup shape now, which I can choose from the list. But since this element has 8 edges, I can define different stirrups for each of them. The changed stirrup is here and I can see it in 3D. I can change the stirrup in this window. I select the reinforcement element and in the settings window I can change the stirrup type on the other edge, which will be visible immediately. Next, I will show the reinforcement of slabs. There are 3 slabs with the same geometry here. As previously, here we can place 3 different types of reinforcements. I select a slab where I will place a mesh element, and click on the slab tool on the reinforcement palette. The settings window appears. On the left side, I select the mesh. On the first tab, I can set diameters, quality of bars, 2D representation and the position of the mesh. On the next tabs, I can set many other parameters. When all parameters are set, I click on OK. Now with this eye cursor shape, the add-on asks which edge of the slab I'd like to place the mesh parallel to. I click on this side of the slab. I choose the No More Reinforcements option, and here it is in 3D. In a wireframe view, the mesh element is visible in the slab with any holes. If the hole is defined in the slab, it will be cut out from the reinforcement, currently from mesh. The position of the mesh is important. It is now at the bottom of the slab. If I'd like to place it on the top of the slab, I go back to the floor plan, select the slab, and click on the slab tool. There is a button which controls the position of the reinforcement. I turn it off. It's important to set the concrete cover. It can be set anytime. Click on OK and place the mesh. Now to check it in 3D. Now there are two layers if the mesh is placed in the slab. Let's go to the rebar. I select the next slab, where I will place the rebar element, and click on the slab tool on the reinforcement palette. The settings window appears. On the left side, I select the rebar. On the first tab, I can set diameters, quality of bars, 2D representation and the position of rebar. Now again with this eye cursor shape, the add-on asks which edge of the slab I'd like to place the rebar parallel to. I click on this side of the slab. I choose the No More Reinforcements option, switch to 3D. In the wireframe view, the rebar element is visible in the slab with any holes. If I want to place another rebar, I select the slab again, click on the slab tool again. I select a different diameter and I change the concrete cover. Click on OK. I select the other side of the slab and click. Check it in 3D. Now we can see that two different rebar elements are placed and the defined holes are cut out from each of them. If I change this hole in the slab, the add-on will recalculate the geometry of it and will adjust the reinforcements according to it. Next reinforcement type, which I can place into a slab, is an edge element. I select the slab, click on the slab tool, and choose the RF_edge element from the list. Parameters and position should be set. In a slab, it should be horizontal. The concrete cover can be set for each side. Click on OK. On the floor plan, the different ID appears on edges. I select this element, open the settings window. As it was in case of walls, I can select different edges and define a different type of stirrup for every edge. But if I click on OK, on the floor plan, a new editable hotspot appears. And if I click on this, the local menu comes up. And I can change the stirrups type here. Now in 3D. It's visible that the complex element is placed in all edges of all selected slabs, including the edges of any openings. Also, we can see that I applied a different stirrup on some edges. We just looked at the wall and slab reinforcement, but we did not talk about the listing of elements. So, next is the cutting list. I placed different reinforcement elements previously. Now I select some elements and I click on the cutting list tool on the reinforcement palette. The small list icon appears next to the cursor and I click somewhere on the floor plan. This list contains all selected elements with their ID, shape, size, diameter, quality, and weight. In the end of this table, we find a summarized weight. Now I listed only selected elements, but I would like to add more to this list. I add one more mesh and one more edge element to the selection. Additionally, I also select the list, and click again on the cutting list icon. The add-on will recalculate the quantity of selected elements and will update the content of the list. In the end, I see the list is much longer. It contains more elements. On the bottom of the list, a total weight is visible. If I have several different quality reinforcements, then the weight of different qualities will be summarized separately. The placed cutting list is an object, and if I want to change the order of listed values, I can. I select the cutting list and open the settings window. Here I can change the order of columns or delete any of them if they are not necessary. I can also change the font type, font size, and some 2D properties of it. In the loaded reinforcement library, we can find a complex element folder and the RF beam object in it. Selecting this element and clicking on OK, I can place it on the floor plan. This element is a complex element and contains 2 rebars and stirrups in whole length. Going back to the floor plan, I select it and open the settings window. On the first settings tab, there is an option to select section profile, the size of it, the length of the element, and the concrete cover. On the right side, I can choose which view of this element I would like to indicate on the floor plan. Let's go to the next settings tab. In this window, I can define stirrup groups and set parameters for them. For each stirrup group, I set different parameter values. Click on OK. The result appears on the floor plan. Here I am able to modify it graphically. Going back to the settings window, I set other values for stirrup groups and changes appear on the drawing. The stirrup groups are possible to change manually with hotspots. In the settings window, I can set parameters that are bigger than the beam, and in this case, the reinforcement runs out of the geometry. All modifications will be visible not only on floor plan, but also in 3D. Now I select it in the 3D window and open the settings window. On the next tab, some other parameters of the stirrup can be set. Next tab. Here I can select the base placement method of stirrups. Next tab. In this window, I can define groups of rebars similar to stirrups. In a different group of rebars, I can define different values, position of rebar groups. Defined rebars appear on the floor plan and I can move them manually to the required position. If I need other diameters for one of the rebar groups, I do it in the settings window. I need one more group for bottom rebars. I add one more. Set the parameters and click on OK. I move them to the right position in 2D view and check it in 3D. On the next tab of the settings window, I can define the shape of each group of rebars. The shape of rebars is possible to modify in the model view as well. When all modifications are done, I create the cutting list of this beam. I select it and click on the cutting list icon in the reinforcement palette. Then I place the list on the floor plan next to the element. I can place this list anywhere on the drawing. The cutting list contains all parts, stirrups and rebars, listed separately by ID, length and diameter. Custom shape rebar. Next is the construction when the standard rebar is not enough, and we need to make a special reinforcement. The best sample for this is the stairs, because stairs have a very flexible shape. We cannot place automatically the straight, horizontal or vertical reinforcement. We have to use a polygon rebar for it. Here is a very simple stair. Let's check it in 3D. Let's see how I can place reinforcement elements into this. I will place everything manually. There are some simple rebars already placed, but now I will place custom rebars into the inclined stair. In the reinforcement solution, I can select the special rebar. I select it and we can see that it is not a standard element. I open the settings window for it. On the Geometry tab, I can select the polygon option from the list. Next to this, the new option appears where I can define the editable hotspots number on this element. I will now show how it works. Let's place the new polygon rebar. Open the settings window, select rebar, then on the first tab, the single rebar. On the next tab, I select the polygon type and click on OK. I place the element. I select this rebar and editable hotspots appear immediately. I'll go back to the settings window and switch off the label. Now I can change the shape of this rebar. I can make the straight part curved, or I can add new hotspots to this section. It shows that almost any shape is possible to create. I did the same modification of the rebar, I just adjusted points of it to the stair geometry. Now to see it in 3D. There are straight rebars on the horizontal parts of the stair, and here there are slanted rebars. And I can list all placed elements with the cutting list function. I select all placed reinforcements and click on the cutting list tool. Then I place the list next to the drawing. Finally, I'd like to show you a complete building where a 3D model is created in ArchiCAD and reinforcements are placed into the construction with EPTAR's reinforcement add-on. This is a floor plan. It is not a complicated building, but it's suitable to show how complex the reinforcements in it are. In a wireframe view, all parts are nicely visible. You can see there are a lot of rebars, stirrups and meshes, but against the huge number of elements, the model is not heavy. I can move it and turn it around easily. It's moving really smoothly. While I know the 3D is nice, in the end we have to have drawings. Here is the section view of the stair, which is quite easy to create. And in the end, I think it's interesting to see the foundation of the building, which shows that it is possible to reinforce all construction types with our solution, which uses all ArchiCAD functions and gives unique tools for ArchiCAD users.